Yeah, I trust our weekend is going on well.
Yeah, it's going on.
Okay, so I'm sorry. I don't know. Network is kind of complicated this morning, but we'll try and see what we can do. So, like I mentioned, today we are going to be looking at the components of CNI solar PV. All right, because without putting those components together, there is no how you can have an efficient system. All right, and like I mentioned to you last week that CNI is different from residential. With residential, you can juggle your health together and say, okay, this is what I want to give to the client. This is the kind of system I want to give to the client. But for CNI, it is not like that. You need to have an energy and power logger. All right, you need to have those. You need to have that too, so that you can understand the patterns of the facility energy consumption. In fact, some go as far as a year. You understand? When you capture the when you capture the facility load for a year, all right, you can make a good judgment with those parameters. So the longer you do your energy logging, the more accurate you have your system. All right, so it's very good for you to have a log. So we are going to be looking at the components today. We are going to be looking at solar panel, which I'm sure you know. It is the main component. There is the generating component. All right, and we have charge controller if you want to use it. Then we have inverters, we have our battery, and we have our BOS, which is balance of system, which I explained to you last week. But today we are only going to be looking at solar. We are going to be looking at solar panels, charge controller, inverter, and battery. All right, so probably next week we are going to see the BOS. All right, so I'm going to be sharing my screen now. So kindly signify if you can see my screen. So can you see my screen now? Can you see my screen? Yes, I think it's visible now.
Yes.
All right, good. So let me share. This is the slide. Can you see it now? So what can you see on the screen? I guess you can see two young men with their tools, trying to screw a solar panel. Then you have the title of what we are doing today, which is CNI solar PV component. Can you see that?
Yes.
Can you see that? All right, good. So let's continue. Please, let's turn off our mic and our camera. I don't want to see our face. Like I mentioned, we are recording. So if you are talking and doing all sort of things, it will disrupt the recordings. And those that are not unable to join us will not be able to use it thereafter. So please, let's mute our mic. If I need you to respond to any question, I will ask. You understand? So let's mute our mic, turn off our cameras. All right, so let's proceed. So these are the trading contents. This is what we're going to see today. We're going to see introduction to the PV system, types of bus bar and solar cell. We're going to see solar panel connection shading, half-cut cell and bifacial modules. We're going to see VI characteristic curve, calculation of tilt angles, azimuth angles, orientation, shadow analysis, distance between PV rows, the panel parameters. We're going to see parameters from the global solar atlas. Then we now move to, those are the stuffs we're going to talk about for solar panel. Then after that, we see inverter and batteries. All right. Then at the end of the training, you should be able to, wake up, and if they tap you that what is solar panel, what are the functions of solar panel? How do you connect it? You should be able to tell them. How do you identify? How do you interpret the charge controllers, the inverter, and the battery? You should be able to explain all that. So let's move on. So now we are seeing the first one, which has to do with the introduction of PV system. All right. So we all know what solar panel is. All right. Solar panels convert solar energy into electrical energy when sunlight or photons strike its surface. So that's the reason why you can only have your solar energy during the day. All right. Because at night there is no sunlight, there is no photon. So that is basically the definition of solar panel. It receives the solar energy, all right, which is the DC, and convert it. All right, so then the next one is that we have the solar charge controller. Now it's very important for you to understand this flow. When you understand this flow, then you can be creative, you can be innovative about anything that you want to do. All right, when you understand this flow, you can select your balance of system appropriately. You can select your breakers, you can select your cables appropriately. This flow. So it's very, very important for you to understand this basic flow of solar panel system. All right, you can see all the main components there. So now the solar panel, it regulates its voltage before depositing it into the battery. Or I'm sure you know what the voltage of the battery is. You can have the voltage of the battery to be 12 volts, 24 volts, 48 volts, depending on the connection that you want to achieve, depending on the system voltage. All right. So once you have that, you need a charge controller to regulate that voltage before it goes into the battery. If that is not considered, then you will damage your battery. And I'm sure you all know that battery is the most expensive component in the system, and you wouldn't want it to get damaged just like that. All right, so batteries are used to store electrical energy so that we can operate our electrical equipment when the sun is absent. All right, so that's the purpose of the battery, to store energy. So in case there is no sunlight, or maybe you don't have enough energy, the battery can augment. So that is the reason why we have battery. Then we have inverter. It converts DC voltage from the battery into AC voltage required for PTC and I facility. So without the inverter, there is no how you can supply power to the facility, because the type of current that is applicable in the facility is alternating current, not direct current. All right, so you need an inverter to do that magic. So that's the reason why we have an inverter. So you can see the flow. Number one is solar panel. Number two is charge controller. Number three is what is the battery. Number is the inverter or UPS. Then supply it to the facility. Now let me tell you this, but don't worry, let me not tell you. Let's continue. We're going to see that in the course of it. We're going to see now what are the advantages of using solar. All right, sorry, I'm a bit slow. Let me put it like that, because we have a lot to cover, and I also want you to get the very best. All right, so if you need my attention, Bashir, are you there? Hello, Bashir, are you there? All right, so if you need my attention, can you use the reaction? All right, so once you use the reaction, Bashir will call my attention, because I'm not seeing you guys. All right, so if you have any questions, simply use the reaction by raising up your hand. Then Bashir will call my attention. So let's observe it that way. All right, so what are the advantages of using solar panel? Now you see someone that once someone you meet someone and tells you that I work in an oil company. All right, even if it is palm oil, you don't want to know. As far as oil is there, you just refer to the person as a big boy. All right, now we are gradually moving to that era for renewable. All right, renewable is beginning to turn to that oil that we used to know then. So if you are knowledgeable about it now, in the near future, when you tell someone that you are a solar energy, you are a renewable energy, the person will see you as a big boy. Just take it like that. We are gradually moving there. All right. Yeah, I'm not sharing my screen now, so let me just share it now. So this is it. I'm sure you can see my screen now. So let me continue. So what are the advantages of using solar? Now, it provides green energies. I'm sure we all know what the transition is all about. Green energy. So solar is, it provides the green energy. Free and available energy. It is free and available. All right. So this is going to be one of the major advantages of it as against oil. Oil can get depleted, but what is it called? Solar cannot. All right. It is there. It is free and available. All right. So can be used locally, which reduces losses. What I mean by locally is that you can decide to institute that you are not running. Operation and maintenance costs are very, very low. We don't have any moving parts. There is that you need to start oiling or greasing, except if you are using tracker. All right. But there are types of installation that you will use tracker. Don't worry, we'll get there. All right. So, but the O&M cost is very, very low. What I mean by O&M is operation and maintenance costs are very, very low. So now PV is silent and easy to install. It's very, very easy. There is no noise because there is no mechanical moving part. So it's silent. Now the disadvantage is that no power at night or low during or rainy season. All right. So if they are telling you that if it is raining, there is no power from the solar panel, that is a lie. There is a solar panel during cloudy or raining weather. The only thing there is that it's very, very low. All right. Now it requires additional equipment and battery. I remember a friend calling me that he wants to install solar. He wants to have solar. All right. That means he wants to install only solar in his apartment, then run the cable straight to his distribution board. Then he can start enjoying power. I told him that it's not like that. That solar panel does not run alone. It doesn't run independent. It depends on inverter and batteries. It depends on a lot of components. But solar panel is the main component, is the main generating component. All right, so it needs continuous cleaning. For it to be generating, you need to do the maintenance by cleaning it continuously, especially for C&I. A residential can decide to leave his panel there without cleaning it. There is no big deal about it. But for C&I, as far as the system is generating revenue, and remember what we did last week, I gave you the main business model, all right, for C&I, which is solar as a service and power as a service. So with those two models, the facility owner, the business owner is not making any upfront payments. All right. The project manager is the one, arranging everything, making the payment available from financiers, from investors, and doing the installation at the facility of the business owner. All right. In the event of making revenues, maybe every year or every month, for a certain period. So if you want to be generating revenue for a certain period, you need to continuously clean the panel. All right. Because if you've done your model and you say, okay, in a month, the panel should be generating X kilowatt hour. All right. That means that it can only generate that if it is clean. So if you have that in mind, you need to continuously clean it. All right. To keep generating that low efficiency, 15 to 25%, depending on the types of the solar cells you are using. But like I mentioned, technologies keep improving. By the time the efficiency will keep increasing. And I'm sure with the use of bifacial module, the efficiency is more than 25%. So technology keeps increasing. All right. So now for high power PV, you require a large area, which is difficult inside urban. All right. Like in Nigeria, yeah, if you're not in Nigeria, just listening to what we have in Nigeria here. In Nigeria here, a bill has been passed already that each state can generate the electricity. All right. Now, Lagos is kind of disadvantaged because it's an urban area. So, somewhere in Surulere, obviously you cannot see this large area. It's not available. All right, somewhere in Ikeja, it is not available. If you want to have a such large area where you can have a ground mount, you can have a capacity ranging 100 megawatts, 20 megawatt, 50 megawatt, you should be going somewhere like Ekpe, Ikorodu, where you have all those bushy area where it's Lagos, but it's a rural area. So that is where you can get it. But other states like Kano, you know, states like Ibadan, you know, states like Osun, all those places, you can have large areas. So that is where all those states, all those rural states have advantage over Lagos. All right, so that is that for the advantages and disadvantages of using solar. All right, so now let's see the construction and principle of operation of a PV panel. All right, it's good for you to know how PV panel is constructed so that you know how to handle it, so that while doing your installation, you know where to have your mid clamp, your end clamp, and the rest. All right, so now let's proceed. Solar panels, like we all know, is an electrical device, all right, that converts energy of light directly into electricity, and the effect is called photovoltaic effect. Anytime you see photo, that is light. So just take it like that. Whenever you see anything called photo, it is called light. Now, it is important to understand the construction of a solar panel in order to take into consideration the dimension when speculating the total area of installation. As a designer, all right, dimension of a solar panel is very, very important because you are designing at the comfort of your home. You are not at the site. You've only visited the facility for feasibility assessment. But when you are designing, you'll be at the comfort of your own designing. So you need the dimension, all right? You need what the height is. You need what the width is. You need what the length is. Don't worry, when we get to designing using softwares like SketchUp, using softwares like PVCase, you are going to see the importance of using the dimension of solar panel. All right, so now let's proceed. So now these are the constructions of a PV module. So we have the frames, all right? Every solar panel, every module's data sheet have a frame. If you check every data sheet, it will tell you the dimension of the frame. So the dimension of the frame signifies the dimension of the module. So when doing your measurement, when doing your dimension, you take into consideration the dimension of the frame. All right, so immediately after the frame, we have the glass. All right, so that's the reason why you can step on the panels while doing your maintenance. It's because of the glass. All right, now after the glass, we have the encapsulant. The encapsulant is like a gum, all right, that glues the glass to the panel. Is actually protecting the panel. If you look at it, it is the glass that is actually protecting the panel, but we have the encapsulant. The encapsulant is like a cream, all right? It's like a cream that you put at the surface just to ensure that the glass is glued to the panel. All right, I remember I was doing some installations some years ago. We actually went to, because they're actually assembling the panels in Nigeria here. All right, so the installation was urgent. So we quickly rushed down to where they are assembling the panel, you know, just to pick up some panels. When we got there, they were actually doing it. So because of the urgency of the job, we hurriedly carried the panel to the site. On getting to the site, it's actually a two-story building. So while we are moving the panel, we realized the solar cell is just, you know, dangling. That simply means that we didn't allow the encapsulant to dry, all right? And that is a big one. So now when you have that, there are a lot of issues that is going to happen, a lot. In fact, you won't enjoy your installation. That is where you start seeing some error code from an inverter. You will start hearing solar. You start hearing insulation resistant failure. It's because the encapsulant is actually gluing the glass to the panel. It's gluing it. It's protecting it from water ingress, from dirt, and everything. So if it is not properly glued, there will be water ingress, and that is a big issue. All right, that is a big issue. It's just like saying you have electricity and water and electricity. I'm sure you know that they are enemies. All right, so it's like having electricity and you're having water. The two does not marry together. You understand? So it is very, very important for you to check your solar panel. That's the reason why for C&I, we don't go for tier 3. We go for tier 1 inverter. Tier 1, Jinko, Trina, Canadian, those are the ones that you go for. All right, and the project managers are aware about this. All right, so now the next one after this, you can see the encapsulant is up. It is also down. Right, after this junction box, after you've done your series connection, your parallel connection, all the cables will come inside your junction box. Inside this junction box, you also have a diode. Don't worry, we are going to talk about that. All right, so that is what your construction of your PV is all about. So now for PV, we have what we call a cell. You can see we have a module and we have an array. All right, so now when I mention cell, I'm talking about, and when I mention array, you should know what I'm talking about. So going forward, I'm going to be using the term cell. I'm going to be using the term module. I'm going to be using the term array. So instead of saying module, I can say solar panel. Solar panel is the assembly of a solar cell. Do you understand that? So when you arrange your cell, you can see inside this module you can have 72 cells, you can have 60 cells, and so on like that. I'm sure when you check your solar panel data sheet, if you glance through the data sheet very well, you will see where they will tell you 72 cells, they will put 60 cells, they can tell you 120 cells, and so on like that. So that is it. So take note of these terms, all right? So now let's proceed. Now let's see how solar cell works. Now the reason why I'm taking my time to explain all this is simply because I want us to be creative and I want us to be innovative. You can build your own solar cell, solar module rather. You can buy cells in the market, do the connection by yourself, and have the module out. You can just do your module by yourself. All right, so now this is how a solar cell works. All right, you can see the energy from this is the sun. You can see this is the photon, which is what I talked about. I told you that anywhere you see photon, it is light. So now each PV cell is basically sandwiched, made up of 2 slides of semiconductor material. And I'm sure you know what sandwich is. Sandwich is like say you have 2 slides of bread and you have butter in between it. So that is what sandwich is. All right, so PV cells are usually made of silicon. All right, there are a lot of cells that we have in place now. There are a lot of innovations that is going on now. Researchers are trying to see which components that is better than silicon, and I'm sure we all know that everything is out now. All right, so there are a lot of researches going on. All right, so now to get this field, OEM, what I mean by OEM is the original equipment manufacturer, like the Jinkos, the Trinas, the Canadian Solars, and the rest. They are OEM, you understand? They doped, that is when they are manufacturing the solar cell, they doped silicon with other materials, all right? Giving each slides of some with positive and negative. So they dope, meaning that they add other materials to it. It can be phosphorus, it can be boron. You understand? Now, they seed phosphorus, you can see, that is one of the materials at the top, into the top layer of the silicon, which add extra electrons with positive charge to that layer. So what I'm trying to say is that you can see what I mean by sandwich is that you have butter in between 2 slides of bread. Now, see the butter as silicon, all right? Then you see the bread at the top as the another one material, and see the bottom bread as another material. So the top material is the phosphorus that we are talking about. All right. So now you can see, meanwhile, the bottom layer get a dose of boron, which results in, so that means that if I'm seeing the silicon as butter, then the top layer as phosphorus, then the bottom layer as boron. So just see it like that. All right. So meaning that when the photon, which is the energy from the sunlight, strikes the silicon, what happened? The phosphorus, which is the top layer, that means that you have both electrons, which is you have both positive and negative electrons moving. All right. So when a sunlight knocks an electron free, the electric field will push that electron out of the silicon. All right. So at the p junction layer, you have at the p n junction rather, you have what we call the depletion layer. All right, where you have movement of electrons. So now this should come to your mind that whenever you see, when during this, when it is sunny, maybe during peak sun hour, let's say around 12 or 1, all right, and you are going past an installation, when you are going past an installation and you realize how the sun is hitting the solar panel, so what should come to your mind is that PN junction has been created, all right, and we have electrons moving up and down. You understand? So once electron is moving, that is where you have your positive and negative. I'm sure you know that for every from every solar panel that you have at the junction box, you have positive and negative. So that is where the electrons are moving. But it is not all about that, all right? Because that is, if you have series of cells, then how do they move? Remember, we are talking about solar cell, how solar cells works. That means just one. We are talking about how this solar cell, how it works. So that means that when your photon hits this cell here, electrons is moving. You understand? So now, what about if we have a module? How does it work? You know, how does it work? That is where we are going to now. And that will bring us to the types of bus bar, all right? Because a cell, you can't just put a cell to have a module. There has to be some connections, all right? So you can see this cell now. You can see this white line. Can you see this white line? Can you see it? I need someone to tell me. Can you see this white line?
Yes, we can.
Yes, we can.
All right. Good. So that white line is what we call the bus bar. All right. So now you can see we now have types of bus bar. We have 2BB. 2BB means we have 2 bus bar. 3BB means we have 3 bus bar. 4BB means we have 4 bus bar. 5BB means we have 5 bus bar. The higher the bus bar, the more efficient the panel is. All right, so that's the reason why innovation keeps coming, and we're going to see the reason why it is better. Now, the purpose of a bus bar in the cell is to conduct the DC power generated by the cell when photon hit the cell. You can see now. So that means that this cell that I'm talking about, when cell, what happened? Current will flow. Now, what will transport this current to another cell, to another cell, to another cell, is actually the bus bar that is transporting the electrons. All right, so that's the reason why you can see the purpose. The purpose of bus bar in solar cell is to conduct the DC power generated by the cell when photon. So now let's leave this bus bar alone. Let's come to the general function of the bus bar. In electricals, we have what we call bus bar. I'm sure you know that. In electricals, we talk about bus bar. All right. In in electrical, we talk about bus bar. In fact, in what's it called? In sound, we talk about bus bar. virtually in everything we talk about bus bar. Bus bar is general. You understand? So the meaning the same meaning that you have now. You understand? And I'm going to explain to you in a layman term. Let me say you have, for example, now you have, let me bring out a word. Now let me bring out a pen so that I can draw and explain to you. All right, so can you see what I've just, can you see a whiteboard? Can you see it?
Yes, we can.
All right, good. So now I want to explain what, all right, good. I want to explain what a bus bar is to you in a layman, all right? So now let me assume that we have let me just assume that we have this boy, all right? And we have, all right, and we have a lot of dependents. Let me just say we have 6 dependents, all right? Now, every now and then, this dependent, they come to this person, all right? They come to this person, they come to this person, they come to this person, they come to all the 6 dependents are coming together. So I can say person is a bus bar. The reason being that everything that this person has, all these 6 dependents are taken from it. All right, so I can person a bus bar. So that is basically the meaning of bus bar. Bus bar simply means that a device, or let's say an electrical device, or simply a device that every other devices depend on. All right. So now let's just continue with our slide so that you can, let's come back to this. All right. So now the purpose of bus bar in itself is to, okay, I've talked about. Now the higher number of bus bar reduce distance between the bus bar, which decreases the internal resistance losses. Now, generally in electrical, we work in such a way as to reduce distance. If you are going to do any connection in electrical, generally, it is advisable for you to reduce the distance as small as possible, so as to reduce the resistance. All right. Now, which decreases the internal losses, and when the internal resistance losses is increasing, this creates lower resistance. Additional bus bar creates lower resistance between cells. So what this is talking about is that when you have like this, now we have 2 bus bar. All right, you can't consider the distance between this bus bar with this bus bar. These 2 bus bar have distance compared to, all right, the distance of is higher than the internal resistance of 4 BB. The internal resistance of 4 BB is higher than the internal resistance of 5 BB, and so on, like that. All right, you the non-electrical person might not know what Ohm's law is, but let me just explain what Ohm's law is. You know, as a science student, we usually obey his law. You know, there is nothing. Let me just cancel this. All right, so what Ohm's law, what Ohm's law basically talks about is that when the resistance go down, all right, the current goes up, and when the current goes up, this voltage, at the same voltage, the power goes up. So that means that let me just do this bit. I want to use the formula so that we can understand it. So what Ohm's law is basically talking about is that V is direct proportional to I at a constant resistance. So this is what it's simply talking about. So when you look at this now, it says that when resistance goes down, all right, the current goes up. So that means that if we have a decreased internal resistance here, what will happen to the current? Current will go up. Do you understand that? When we have a decreased resistance, so that means that if you have a higher BB, that is like we have a 5 BB now, what will happen to the internal resistance? The internal resistance reduces. And when the internal resistance reduces, what happens to the current? Current will go up. And when current goes up, what happens to the power? The power will also go up from P equals to IV. I'm sure you know that formula. Everyone should know that formula. Even if you are not a science or electrical person, you should know that formula. P equals to IV. So that means that once the current is increasing, power is also increasing. Once the resistance is going up, and once the current is going up, the power is also going up. So that means that if we have 5 BB, 5 BB will have more power than 4 BB. All right, 4 BB will have more power than 3 BB. 3 BB will have more power than 2 BB. So that's the reason why if you are doing, your procurement for CNI, it is best for you to watch out for the bus bar, because the higher the bus bar, the more power you have. Do you get that? So let's move on. All right, so let's see the next slides that we have. Last week, someone asked what is monocrystalline. So we are here now. So types of PV cells. We have the monocrystalline solar panel. All right. One of the most effective of the solar is the most effective because of the efficiency, 15 to 24%. They require less space than other cells simply because they produce more energy and can yield up to 4 times power than the thin film solar panel. We're going to see thin film solar panel. So they produce more energy, so as they require less space. They also last longer and perform better at low light. The only disadvantage is the costs, but notwithstanding, we know that the duration for this guy is it can last for 25 years. All right. So considering the cost, you must have factored that into your financial model. So cost will not be any burden to you. That is the reason why for CNI we go for the best, which is monocrystalline. There is no CNI project that you see that they are using crystalline. No, because it has a lower efficiency. You can see with a polycrystalline with an efficiency of 13 to 16%, it is often a better economic choice. Yes, for the residentials, for someone that after you've given a quote to and is saying, the solar panel is expensive. For residential installation, they don't want to pay. So you can go with polycrystalline. Now, the main disadvantage is that you need more of them because of the lower conversion efficiency. You need more so as to meet up with the capacity that you need. All right. So for CNI, we go for monocrystalline solar panel. So now this is how your poly looks like. Anytime you see something like this, it is poly. You can see, in fact, in terms of neatness and in terms of arrangement, monocrystalline is still okay. In terms of aesthetics, it's okay compared to this. You can see this one is rough and dirty. Now let's move to the next one. Amorphous or thin film solar panels. At 70%, they are among the least efficient in the market and also the cheapest option. All right. Now the main disadvantage is that it is suitable for a situation where space is not a big deal and it degrades quickly. So if you want to beautify your house and you need your house to look good, you can go for amorphous or thin film, but the efficiency is low. That is the reason why CNI will not use this. CNI, you will not use this. And I'm sure you know that that's the reason why something like this is not really, they don't really propagate something like this. Because what is it is not giving me back my money. Everything is all about money, all right? Because there's an investor. You can't be pitching to the investor now and be telling the investor that when we go for this panel, it's good to the investor will not want to hear that. What they want to hear is that once we install this, within 2 years, we'll get our money back. Investor is all about money. So that's the reason why we don't usually propagate this. When it comes to CNI, this is the best monocrystalline solar panel. All right, so let's move on. We are going deeper. Solar panel connections. This connection is very, very important. Very, very important. In fact, after this class, you should have this at the back at your palm. All right. You should know what this connection is all about. Now, panels are connected in series forming strings to increase the voltage, the total voltage. These are connected in parallel, forming arrays to increase the total current. Now let me go back to the solar panel now. Can you see the solar panel? Can you see the solar panel? Solar panel is the number one component of the system, followed by charge controller. Now, the reason why we need to connect in series is to meet the condition of this charge controller. All right? The reason why we need to connect in series or in parallel is to meet the condition of this charge controller. Now, most residential installers, they don't know about this, and the way they do it is that they just look at you should be able to connect it. It's not like that. It is not like that. If you've been doing that, after this training, just desist. Do your proper connection so that you will not burn the roof. All right, so that you will not fry someone's apartment. All right. Now, let me come again. The reason why we connect in series and in parallel is because to meet up with the condition of this. And the reason why I'm hammering it is because I don't want you to cram it. Once you already know the condition to be fulfilled by this charge controller, then you will know how to arrange your panel either in series or in parallel. Now, most charge controller, if you see their data sheet, they will tell you that MPPT range, they will tell you 15 to 500, you understand? They will tell you the current is 50 amps, blah, blah, blah. Now, once you see that, then you will know that, okay, for me to be able to match up with this connect my panels in series or in parallel. All right, so don't worry. When we get to design, you'll see all that. I just need to tell you what the series and parallel connection is. So now, when you connect in series, all right, you are actually increasing the voltage. For example, now, if I'm told that the MPPT voltage range is between 300 to 600, all right? But if you check a solar panel data sheet, you will never see MPPT voltage range as 300, 500. It's not possible. You will never see it. Till Jesus comes, you will never. What you will only be seeing is they will be telling you maybe before or 33 types of the module. That is what you'll be saying. So that means that if you are seeing 30.5, for example, now, that means that you need to arrange that 30.5 in series so that you can match up with that voltage of 300 to 500. I'm sure you understand what I'm saying. All right? I'm sure you understand what I'm saying because you need to get this one very well. I'm sure you understand what I'm saying.
Yes, sir. I understand.
All right, good.
Can you come again, sir?
All right, good. All right, good. I'll come again. So what I'm saying is that for you to be able to match up with the voltage that is required by the MPPT, remember we are following the flow. Remember when we started with I showed you that you need to understand this flow. I told you that you need to understand this flow. All right. Once you understand this flow, you'll be able to size everything that you need to size perfectly, from solar panel to charge controller to battery to inverter and to your facility. All right, so connecting panels in series. First, let me start with series. Now, I said that series parallel connection will increase the total voltage. For example, now you've checked the charge controller that you want to use, and you are told that the operating voltage of that charge controller is between 300 to 500. And if you are checking the data sheet of your module, you will never see 300 or 500 there. What you'll be seeing is 24.5, 30.6, 44.3, 55.6, depending on the capacity of the module. All right. So now for you to now meet up with that 300 or 500, you need to connect in series to meet up with that. And how do you do that? You need to increase your voltage. When you connect in series, you are increasing the voltage. And when you have that, you are forming a strings. You can see this is a cell a module. In fact, this cell now, to have this, I'm sure you know that inside this cell now, inside these cells, there is a series and parallel connection also to have these cells. Remember, a cell, I didn't tell you, a cell has a voltage between 0.3 to 0.5 volts. That is a voltage of a cell, 0.3 to 0.5 volts. Now, inside this module, you need to connect also in series to increase that it can be 0.5, to increase that 0.5 to the voltage that you will eventually have of a module. If you check a module data sheet, you'll be seeing 24 volts, 25 volts. That means that they've connected that cell in series to increase the voltage so as to have a module. Do you understand that? So you can see now I'm connecting in modules in series. So this is the series. When you now connect in arrays, that means you have the series, you now connect the series in arrays. You can see you now have when you connect in parallel, you have an array. So you can see panels are connected in series, forming strings. When you connect in series, you are forming a string. When you connect in parallel, you are forming an array. Do you understand that? So in parallel, increase the total currents. All right, ask your question.
Please, when you say series and parallel, I know probably some people may have this question. Is it positive to positive, negative to negative?
All right, we'll still come to that. If you see the image that I have under, it talks about that. Can you see it? Can you see it? So connecting in series, all right? You can see that every solar panel has two probes. It has positive and negative, all right? So when you connect in series, you can see now you are connecting. You can see this panel. How many panels do we have here? 1, 2, 3, 4, 5. I have 5 panels. You can see every panel have positive and negative, positive and negative, positive and negative, positive and negative. So now when you look at this now, to connect in series, I'm simply connecting the negative of one panel to the positive of another panel. Negative of that panel to the positive of this, negative of this, positive of this, negative of this, positive of this. So at the end of the strings, this is now a string. At the end of the string, you have a positive and a negative. Do you understand that? So that's the reason why if you are doing commissioning, at the end of, you've done your installation, at the end of commissioning, you have to test. You have to test if the voltage is actually what you want. Now for parallel connection is that you take all the positive together and all the negative together. That is for parallel connection. Is that understood?
Yes, sir.
Is that understood? Don't worry, by the time we start doing the design, you understand it. All right, so now let's move on. This is a barrier for solar generation. You can see shading and half-cut cell. You can see this is an installation. Who will do this? I'm even asking, how will someone do something like this? Can you see it? Why would someone do something like this? You can see this is a pole casting shadow on this panel. You can see another tree casting shadow on this. Now you can see the effect of partial shading of solar PV. You can see if you arrange this module in series, there is no shading. You are going to have full generation. Can you see? Now if you arrange this, you can see part of it is shaded. You cannot have full generation. You can see also again, the shading of this is more. This is the generation that you're going to have. Now, if you have something like this, obviously you cannot have full generation. I'm going to explain the effect of this. We're going to see it. Now, when you look at this, there is what we call bypass diode. Now, how many of you know that inside your junction box, you have what we call a diode? How many of you are aware about that? If you are not aware about that, you can go out and do the experiment. If you know any module, if you have any modules with you, just open the junction box. You will see a bypass diode there. If there is no bypass diode there, then that means that our panel is produced in 1985. All right? So I'm sure we all know that there is a bypass diode in every junction junction box of a PV module. Now we are going to see the function of the bypass diode. The bypass diode is not just there for fancy, it is there to prevent complete losses in terms of shading when we have shading. Now let's go. Now you can see this is a bypass diode. Bypass diode. So this is it. Now on this panel now I have a bypass diode. On this panel I have a bypass diode. This as well I have a bypass diode. Here I have a bypass diode. Now when you look at this cell, now there is no shading here. Bypass diode we move naturally, we move. Now because there is a shading here, you can see shadow. The bypass diode will move the current that is already flowing, it will bypass this. It will assume that this panel is not here at all. Then it will move it down to this. Now we are going to see the effects. Now you can see shaded. This is unshaded. You are going to have 100% generation. You are going to have partly. This one is partly shaded. You are going to have few percentage. If it is shaded, you are not going to have generation at all. Now let me explain this. I'm going to explain this. Let me use this to explain. Can you see let's see the function of our bypass diode. Let's see. I'm going to explain. I need you to listen very carefully. Let me just close this and open it again, so that you understand what we mean by bypass diode. Now let's see. Now I have this panel. This is my panel. I have another panel. I have another panel. I have another panel. I have another panel. Let me assume I have 5 panels. Now the voltage of this panel, I'm assuming, you know, every panel has what their voltage. Let me assume that the voltage is 20. Let me just use then the current is let me use the current is, let's say 5. All right. Now when you connect this in series, what is the meaning of series? Remember, when you connect this in series, what will be, remember the voltage is what, 20, and the current is. Now when you connect this in series, let me assume that there is no shading. I'm connecting this in series. I'm connecting this in series, positive to negative, positive to negative, positive to negative, positive to negative. So at the end I have negative here. I have negative here. At the end of this I have positive. So now when I test this, all right, what should be the voltage? I want to know if you're actually following. What should be the voltage? What will be the total voltage?
40.
No.
100 volts.
I have
100 volts.
Now let me use this to explain. Connecting in series. Please kindly mute your mic. If you are connecting your module in series, you are increasing the voltage, but the current stays the same. The current is not affected. You do but the voltage stays. I'm sure you understand that now. Now we have 5 modules here now. We are connecting it in series. So what will be the overall voltage? The overall voltage will increase 20 plus 20 plus 20 plus 20 plus 20. That will give us what? 100. All right? But the current will remain the same. So that means that if I'm going to look at this now, I'm going to ask why my current will be what? 5. Do you understand that? Do you understand that? Hello, do you understand that?
Yes, sir.
Hello?
Yes, really. Yes.
All right. Sorry. Just give me 30 seconds, please. I'll join you. All right. Sorry, I'm back. So it's gonna be what? Can you hear me now? Can you hear me?
Yes, loud and clear.
All right. All right. So we are going to have a volt and 5 amps. So that means at the end of everything, the power that you'll be generating will not be what? Remember, P equals to VI. So that means the power that you'll be generating will not be what? 100 times 5, which is what? 500 watts. Do you understand that? Do you understand this?
Yes.
So do you understand this?
Yes.
All right.
Well understood.
All right. Good. So this is in case there is no shading. All right. In case there is no shading. Now let me now assume. I want to give another scenario again. Now let me assume that there is a shading and there is no bypass diode. Remember, I told you that if you check the junction box of your solar panel, you see a bypass diode there. Now let's see I want to do this. Let's assume that you open it and there is no bypass diode there. And remember, I told you that if you check a panel and there is no bypass diode, that means that the panel is manufactured in 1986. So now let's see how to simulate this if there is no bypass diode and this panel, let's assume that this panel is shaded. Let's assume that this panel is shaded. This panel is shaded. All right. And remember, the voltage is still what? 20. And the current is still what? 5 amps. 5 amps. And this is 20 voltage, 20 V. All right. Now let's see. Remember, we are connecting in series. The same principle, increasing is connecting in series will increase the voltage, the current will stay the same. Now remember, this is shaded and the panel we are using has no bypass diode. Now let's see. Now when I'm passing the current from this side, the current is flowing from this panel to this panel, flowing from this panel to this panel, flowing from this to this, flowing from this to this. All right. Now because this panel is shaded, and there is no bypass diode, what will happen? The current that has been rushing, because there is a shading here now, it will reduce this current. Because it is shaded, it will reduce the current drastically. All right. So what will the current be now? If I'm going to do my, so this will now give me what? This will give me what? How many panels we have here now? I have 1, 2, 3, 4. So what will be the overall voltage? I need someone to tell me. What will be the overall voltage?
80 volts.
80 volts.
Yes.
Are you sure?
Yes.
I need someone to tell me what will be the overall voltage.
It will be 20 times 4. 20 times 4, 80.
It will be 100
Alright.
volts.
Well,
sir.
It will be 100 volts, right? So
Yes,
what will be
it
the
will be
current?
100 volts. The current will be reduced. Maybe probably 0 or half of it.
All right, I need someone else to tell me. Let's make this to be interactive. I want to see those that have been installing since. I'm sure in the house we have some installers. So I need someone to tell me what would be it is shaded and there is no bypass diode. So what would be the overall power?
0.
The overall power will be 0.
It will be 0. If there is no bypass, if there is no bypass diode, it will be 0. If there is no bypass diode.
It will be 0.
Yes.
It will not be 0.
Okay. Now let me just explain this. Now it will not be 0 because if it is 0, obviously any panel that is shaded will not be generating, but it's obviously generating. But the effect of it is that the generation is not much. So now because of this, now I'm going to have the current to flow. So that means the total panel that I have here will still be what? 100. All right. But because I have the shading, the shading will reduce this to what? We reduce the effect of this current. The current will reduce to what? To 1. So what will be my power? My power will now be what?
100 watts.
Will now be what? Is it?
100 watts. 100
Sorry,
watts.
that's 100
Watts.
100 watts. All right. So now this is it. Let me use this to. I'm trying to This is what it is so that you can see. Can you see this image clearly? So that you can see what we mean. Let me use this to explain so that you get. Can you see this image clearly?
Yes.
Now, when you look at this, let me use this. When you look at this now, what do you have here? This dot means you have 3 panels. This dot means you have 3 panels as well. Can you see it? So that means the total panels that we have here is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 panels. Do you understand? Hello?
Yes, we do.
All right. Now, the same thing with that one. Now, on this now, you can see we have bypass diode. Bypass diode. But in this case, we don't have bypass diode. All right. Now, when you look at this now, when you look at this now, this is actually, we still give me 5. Let me cancel this so that you get it very well. This will still give me my 5. This is it. Okay. Now, my voltage will give me 20. That is the voltage times, I still have my 5, but the current will drop to what? 1 from 5. Do you understand that? Because there is no bypass there. So at the end of everything, you are going to have what? 100. Do you get that? So that means you are going to have 100 watts. That is the power. Now, because you now have a bypass diode. All right. So now let's see the function of bypass diode. Because of the bypass diode, we assume that this panel is not existing. Do you understand that? It will assume that this panel is not existing at all. So because of that, it has reduced the number. So you are going to, instead of 5, it has reduced it to 4. Are you with me now?
Yes.
Yes, the current will still stays the same. The current will stays the same. So you give me what? 20 times 4 times 5. What is it? What's what?
400.
Sorry?
400. 400.
400. So you can see now. So you can see without bypass, without bypass, 400. So you can it becomes very weak. Start extremely wide, saying that if you're running with a full force, all of a sudden you hit a giant. Once we hit a giant, what we have put your energy use with start, energy will drop. So that is what has happened to this current here. As the current is coming from one panel to the other, immediately to this shared one, its energy reduces to 1. All right, so that's the reason why you still have this. But because of if you have a bypass diode will not allow the current to touch this shaded power. It will take it automatically. All right, it will take it automatically. We assume that this panel is not seeing this panel. You understand? So that's the reason why you have, even if it is shading, because of the bypass diode, you still have significant power. You understand? Remember, with bypass diode and there is no shading, we are having 500. You understand? But with a bypass diode and it's still shaded, we have 400. So at all, now in bypass. Do you get that? So that is it with bypass diode. All right. So now let's move on. Any question with this? I think someone asked a question. Any question?
I have.
Emeka, you want to ask a question? Mute yourself and ask.
Okay, thank you, sir. So my question is that shadow, is it the cells that it affects? Supposing the shadow is casted on the cells of the module, is it the cell or the entire PV module that will be affected?
Okay, thank you. If it touches the cell, the entire module will be affected. Remember, I told you that a cell forms a module through series and parallel connection. Do you understand that? I told you that a cell has a voltage between 0.3 to 0.5. All right. So, but if you check a panel, you will begin to see 20 volt, 23 volts. So that means that those cells have been connected in series. all right, to form a module. So even if it is a cell that is affected, it affects the whole system. Do you understand that? Do you understand that?
All right, sir. Yeah, thank you.
So even if it is a module, you understand, even if it is a cell that is affected, that's the reason why we sometimes do maintenance. If you check your module, you understand, you notice that your module is slanting, it's tilting at an angle. All right, you notice that at a point, you notice that dirt will accumulate at the downside of it. At that downside of it, it is actually covering a cell. You understand? It's covering a cell. Because it's covering that cell also have an effect. You understand? It can affect the whole module. So it's best for you to always avoid that. All right, so now let's move on. We still have a lot to cover. All right, so this is what I'm explaining. When a shadow is cast on a panel, whether a tree or a building, it would see that we don't want to take time. We don't want to lose any amount of electricity. All right. Now, shading of just one cell in a module, can you see it now? This cell can reduce power output by as much as 33%. You can see it's more. All right. Now, without any form of shading, the number of panels remains the same, and the energy output is maximum, just like I've just explained to you that we have 500. Now, by using a bypass diode, I'm not explaining this now, I'm explaining this. By using a bypass diode, we cancelled the shaded panel. Bypass diode is assuming that panel is not existing. All right, we cancel the shaded panel. Then we have 9 panels instead of 10. But the same operating current, which is 8, you can see, we have 1, 2, 3. The dot, like I mentioned to you, is a panel. So overall panel is 10. So bypass diode is assuming that it's canceling out this panel. It's assuming is not having current, still stays the same. All right, still stays the same, which is 8. Now, in case of keeping the shaded panel without a diode, all right, if you are using a panel 1985, is no bypass diode, the number of panels will be higher, which still remains 10, but the current will be reduced a lot, so like 1 amps due to shading effect. So the total power will reduce compared to where we have. I think this has everything that serves as a short part to allow current to bypass the faulty or underperforming module. All right, so that is the function of a bypass diode. So when you open a panel and you see a bypass diode there, you show it. So at times, by the time the installation is going close to maybe 5 years, 10 years, 3 years, you know, that is, I mean, by 5 years, 10 years, 3 years, you start, the bypass diode can get faulty. That's the reason why for C&I, we do maintenance. We monitor what is going on. So once we realize we are not getting maximum energy output that we should get, we start troubleshooting, and our troubleshooting can lead us to a faulty panel. So what do? We replace the panel and bring in another one. You understand that? So that is now improving, you know, to reduce the effect of shading. We have what we call half-cut cell. I'm sure you must have seen that. Now, in most C&I installation, in fact, we don't use this type of cell again. This type of cell is called monocrystalline, full cell monocrystalline. We don't use it again. I'm sure you know that. I mean, you know, called monocrystalline. So this is it. All right. So now let's see. This technology increased the energy output by reducing the size of cells. All right. So more can fit on the panel. The panel is split into half, so the top operates independently of the bottom. So this is it. You can see this is the one you usually see. And the half cut cell, this is how it looks like. Now let's come to this. So this is it. Let's explain this. This is a full cell. This is a full cell bypass. You can see, if you see a full cell, you notice that the junction is always at the top. The junction box is always at the top, just like this. You can see. But if you see half-cut cell, the junction box is always at the middle. I'm sure you must have noticed that. How many of you have noticed that before? Have you noticed that before? For full cell monocrystalline, the junction box is at the top. The junction box is always at the middle. Emeka, you want to ask a question again? Emeka, you want to ask a question again? Unmute yourself and start.
Mixing that half cut to bifacial.
No, we have half cut cell that is bifacial. Do you understand that? Do you get that?
Okay. Okay.
We have half cut cell that is bifacial. We have full cell monocrystalline that is bifacial. Do you understand that? You can have this is a full cell, but it is bifacial. This is half cut cell, but it is bifacial. Do you understand that? So you are still facial. Okay, someone wants to ask a question. Let's see. Anybody want? Okay, Femi, you want to ask a question? Ask your question now because we still have a lot to do.
Yes, sir. Like, I just want to ask that what advantage does the half cut have over the monocrystal?
We are going there. We are going there now. All right. So this is it. We are going to see the advantage now. Now, if you have a full cut cell, all right. Now we can see. Remember, I told you that this is one string, this is another string, and this is another. If you open the junction box of a full cut cell, you can see at times you can see three bypass diodes. At times you can see two bypass diodes. You understand? Now, when you look at this now, you have that means that this string bypass diode is taking care of another string. Another bypass diode is taking care of another string. Do you understand that? Now, when you look at this full cut cell, but before that, let's look at this case of 60 cell. Now, if there's shade, all right, if there's a shading here, you are losing one third of the string by the bypass. Can you see? This is a full cut cell. Now, let me assume that I want everybody to bring out your calculator if you are using it. Now, let's assume that this cell now, let's assume that this module is 500. Let's assume that the module is 500 watts. All right? It's 500 watts. One third of it. You are losing one third of it. Now, even if it is just, forget about this, even if it is just all this, even if it is just this small part that is shaded, you are losing all these parts. Even if it is just this small part, all the string. Now, so let's assume that this panel is 500 watts. So now, if you are losing one third of this power, one third of the power, you want to tell me, I didn't want to tell me what will be the power.
8 of 3.
But that means out of 500, you are losing 3. You know how we go?
Plus 62.
333.
That's 333. That means when you are losing 1/3 of that power because of shade 500, it's going to be generating what? 333. That's 333 watts, which is not acceptable when it comes to CNI. All right. Now let's go to our half-cut cell. Now, because of this half-cut cell, when you look at this, you can see now half-cut cell, you have this string at the middle. Can you see? So now instead of having the full, it is dividing one cell into two. All right. So you are going to have 6 strings, 3 at the top and 3 beneath. Can you see? Can you see it now? You have 6 strings. 1, 2, 3, 4, 5, 6. Can you see it? So now if I'm in this module, if I have shading in this module, that means I'm going to lose only 1/6 of the power. All right. So if I'm losing 1/6 of the power, how much will I have left? What will be the power of the module?
470.
470. I see. Comparing with 3. So, but that's a single. Remember, for CNI, we are not using just single panel. So you can imagine the accumulated losses if you have 500 panels, 300 panels, 1,500 panels. You can imagine the accumulated losses. That is a whole lot. So that is the effect of half-cut cell. Please mute your mic. If your mic is not, please mute your mic. Emmanuel Moses, mute your mic. So you can see the importance of half-cut cell. So that's the reason why we are using the half-cut cell, so as to reduce the power losses. That is the function. Does that answer your question now, Olufemi? To reduce the losses in terms of, so you can see, in the first case, 60 people divided by, now in the next case, now, the power loss is generally proportional to the square. I'm sure you know what power loss is. So now let me just do this. Let me bring out my page so that let me cancel this. So that I want to explain why you have the losses. Now, let's see. Now you can see my screen. Generally, power loss is what? I squared R. Your power loss squared R. Or electrical students should know this formula. So now, if you have a full cell, this is a full cell. You have a full cell. All right. What is the current? The current of this is simply I. So you are is that it could be I over 2. I over 2. Am I right? Am I right? Hello, am I right?
Yes, sir.
Yes.
Good. So if I have this, that means that my power. Now, when you look at this now, in this case now, if I'm going to consider the power, if I'm going to consider the power loss in this case, it is what? 100%. If I'm going to have losses here, it is really 100%. But if I have an half-cut cell, put this current here, put it here, that will give us what? Half over 2. Am I right? Half over 2, all squared times the resistance. This is it. So my power will give me what? My power, this will give me I times I will give me what? I squared. Am I right? Am I right?
Yes.
Yes, sir. Yes, sir.
So all this will give me what? I squared over what? I squared over what? Over. So this will simply give me 1/4 I squared times R. Am I right? I squared times R. 1/4 is 5, right?
0.25.
Yes, it is.
0.25. So Now, if I see that 5%, which is what we have here, instead of the complete 100, which is what we have here. So when you look at this now, this is it. Therefore, when cutting a solar cell in half, these are reduced by a factor of 4 or by 75%. So you can see the importance of half-cut cell. So you see, nobody is using of a cell when the amount of electrical current that is carried by each bus bar is reduced by half, just like I've just explained to you. This decreases the electrical resistance of the bus bar over it decreases electrical resistance within the bus bar. Remember when we did but resistance, and once the current is increasing, you are increasing the power, and that will increase the overall efficiency. All right, now it is predicted the net share of half-cut cell will jump from the, I'm sure it has jumped already. Nobody is using, don't know it is full cell that half-cut cell that everyone is using now. So you can see for before we move on.
All right. So speaking about the half-cut cell, so that's economical now, more effective.
Definitely, yes.
So what I want to ask
is more effective.
Yeah, when did this technology, they are using the full monocrystalline PV module. Then question is that formula, the way you arrive at the plans for this thing, where you substituted the so maybe take it again, sir.
Okay. All right, thank you. So just to let you know, I've been in place for long, and most CNIs are using it. If the reason is because of maybe they've done their calculation and they realize that they can use, probably there is no shade in there. You understand? About CNI. Everything that you say about CNI is rocket science. It's not you have to use it. There has been some background analysis that has been done. All right, that has been done to ensure that at the end of everything, let's go with let's go with half-cut cell, let's go with monocrystalline. Do you understand that? So it's not a must that you use full cut half-cut cell. You can also go with the monocrystalline. This is I realized that along the line there can be some shading. Obviously, when you do your plus and minus and you realize that no. For example, now if I'm doing installation in a place that I know that is a bit, you understand? I know that it's a bit dusty, I can decide to use half-cut cell. But I can use half-cut cell if I've done my model, my financial model, and I realize that I'm good to go, then I can do half-cut cell. For example, now, let me assume that somewhere in Kano, solar radiance in Kano, I mean the sun in Kano is more than in Lagos. But where I want to do my installation is dusty. I can decide to use half-cut cell. It's because I do that because it's dusty. It can get to a point that some dust can begin to cast shadow on my module. But if it casts shadow on my module, at the end of everything, I can still realize my money easily. You understand? Because of the solar irradiance, because of the sun that is there. But somewhere in Lagos now, the sun is not that much compared to Kano. So when I do my plus and minus regarding the energy from the sun, I can decide to go with full cell. That's a full cell monocrystalline. So that is it. So now they get back your full cell, the current that is passing through your full cell is simply a current. But when you divide it into two, the current that is passing through here is divided. The current here will not be half. The current here will not be half, which is half over 2, half over 2. When you combine everything together, you still get I. I'm sure you know that. Right? Now, when you put this into this formula, this is what you're going to get. Use this for 1. This is it. This is it. When you use this for 1, this is it. You have 2 here, you have R. Let me cancel this as well. So this is it. So I squared will still give us I squared. Then 2 squared will give us 4 times your R. So when you split this, you still have 1 over 4 I squared times R. 1 over 4 is 0.4. In this case now, whenever there is losses, it is completely 100%. You understand? Whenever, for example now, if there is going to be any loss in this now, it's going to be 100% losses. But because I'm having half cut cell, if there is going to be a loss on this now, it's not going to be 100%, it's going to be 75%. Do you understand that? Because I'm dividing the cell into 2. So that is that. So for half cut cell, I'm not saying you shouldn't use full cut cell. It depends on what your financial model is. Everything is all about money when it comes to C&I. So you have to be very careful. All right, so now let's continue. Let's see the characteristics of VI. This is also very, very important. Very, very important. This talks about the behavior of your solar panel. That is just it. So when you see this, this is your I short circuit current, I max, you have VOC, you have I max. So when you check every data sheet of your solar panel, these are the parameters that you see there. VMP you see there. All right, so now this is a relationship between its current and voltage under a given sunlight. All right, so you have these characteristics during peak sun hour, during the day. These characteristics is not playing at night when there is no sun. All right, and temperature condition. All right, it is obtained by measuring the current and output voltage of a module while varying the load. The load that we are talking about is when you connect your load to it. For example, now you have your residential installation. You have your module in the roof. Remember, when you are drawing the load with the effects of your charge controller, all these characteristics will be changing. All these characteristics will be changing. That's the reason why for C&I, once you've done your installation, we do commissioning. Commissioning, you apply the loads to it. You see the behavior of all these parameters. You see whether it applies to your design, because you must have done your design before you do your installation. And during commissioning, you now see if it's playing out, if the installation is actually playing out what you designed before you are good to go. All right, now this is important. It is important to know that voltage and temperature have an inverse relationship for your PV module. You should know that voltage and temperature all right, that is, and as such, we need to calculate the adjusted module voltage under positional conditions. Why, if you want to do an optimal string design, well, you are going to see all this. All right, so now this is it. Where NPP, that is where the current multiplied by the voltage result, and this is the point. VOC, where the voltage is at its maximum for a particular temperature and current equals 0. VMP, where the voltage value intersects the MPPT. ISC, where the point of, I don't like definition. I just need to I need to see how the play acts. All right. So now let's look at the effect of solar irradiance. I'm sure you know that irradiance affects your solar panel. When you look at this now, this is my current and this is my voltage. Now let's just say this, that your irradiance have more effect on the current than the voltage. So this is it. You can see when the irradiance is 250 watts per meter square, you can see how the current is jumping at a higher pace. But you can see the voltage. The voltage is just moving gradually. All right. So the solar irradiance has more effects on the current. Now let's look at this. Now let me give you this scenario. Let me explain this to you because it will also help you in troubleshooting. Now, I have a site that I asked someone to go and troubleshoot because I got a complaint that the site is not generating the required energy. So I sent someone to the site. So when the person got there, I told the person to start troubleshooting. And he got there around, let's say, he got there around 4:30. So when he was troubleshooting, the question I was asking him has to do with my knowledge about solar irradiance. Now, he got to the site around 4:30. Obviously, the irradiance is not much at that particular period. All right. So now I told him to check what the panel is. What is the parameters of the panel? He told me that the current of the panel is around. He told me that the current of the panel is around 12 amps. That is the current of the panel. So I told him to measure the current using his clamp. Measure the current using the clamp. So when he measured it, he told me that the current is around 11 amps. I told him that that's not the current that he's measuring. I'm sure you know where I'm going. The reason why I knew that he wasn't measuring the current is simply because at that particular time, all right, the irradiance is low. And if the current in the data sheet of the panel is 12 amps, obviously at that particular time, I'm expecting the current to be around 1 amps or 2 amps. But he told me that he's getting 12 amps. So automatically I knew he wasn't measuring the right parameter. All right. So I was able to say that based on my knowledge with irradiance, I already knew that based on my knowledge that irradiance has higher effect on current. So that means that if a particular panel from the data sheet has a current of let's say 20 amps, or no, let me not go there. Let's say 12 amps or 13 amps. Now around 9 a.m. in the morning, if I'm checking the current, I should be getting 12 amps. I should be getting probably 2 amps, 3 amps. But if once I get to probably around 10, 12, 11, 10, 11, 12, 1, 2, those peaks on hour, I should be getting something close to that 12. Considering losses, I should be getting maybe if I'm getting 5, or if I'm getting 6, or if I'm getting 7, I should know that, I'm getting something close by. So it's imperative for you to understand the effect of solar irradiance on solar panel. Now let's move to the next one, which is, okay, no, this is it. Solar irradiance definition. This is the power per unit area received from the sun in the form of electromagnetic radiation. It is measured in watts per meter square. You can see the units. Sun watts per meter square. All right. Now, an increase in solar irradiance leads to increase in output current. I've told you that, which enhances the of a solar panel. Irradiance has large effects on short circuit currents, while the effect on open circuit voltage is relatively weak, like I told you from this. I've mentioned that earlier on. Now let's quickly move to the next one, which is effect on temperature. Now temperature has effect on open circuit temperature. If you increase the temperature, it will affect the temperature. Now, you can see panel. Every panel is manufactured under a condition that the temperature is 25 degrees Celsius. I'm sure you know that if you check the data sheet, of the solar panel, you will notice that you usually see STC, all right, standard test condition, 25 degrees Celsius. You will see it at every data sheet of the panel that you see. Now, that means that if you increase the temperature, maybe you install your system under an unhealthy temperature, you will reduce the system. Now, this is it. For every degree above 25 degrees Celsius, a solar panel output can decrease by 0.3 to 0.5%. Now, let's use 5%. Let's assume that you installed one panel. Let's start with one panel. You installed one panel and the temperature increases above 25 degrees Celsius. Let's say it increased to 26 degrees Celsius. Let's say it increased to 26 degrees Celsius. Now, and the solar panel, the module capacity let's tell me the energy from what would be the output from that panel? Who can tell me?
That's
what
half,
would be
250.
the output from that panel?
250 watts. 250 watts.
Are you sure?
0.5.
2.5 is 250 watts.
Now, let me come again. Now, for every degree above 25 degrees Celsius, the solar output panel decreased by around 0.3% to 0.5%. Now, let's use 0.5%. And the module capacity is 500 watts. All right? It's 500 watts. Now, the condition that the module is installed warranty a temperature, it gets a point, we have a temperature of 26, we have a temperature of 26 degrees Celsius. Now, I need someone to tell me what would be the overall, what would be the energy, what would be the output of that 500 watts? What would be the output of that 500 watts? Remember, we are using a 0.5%. So when you divide that 0.5% by 100, you're going to have 0.005. Multiply it by 500. That means you are going to lose 0.25 minus 500. So that means that instead of the panel to yield 500, it's going to be yielding 497.5 watts. It is just one panel. Now you can imagine the accumulated losses. That is the reason why temperature is a key parameter when designing your system. Temperature is very, very important when designing your system. You can't design your system without factoring temperature. If you are designing a C&I system without factoring temperature, you are just playing. You've not really started. You just realize that, in fact, you will run at loss. All right? It is what Yoruba people will call bese. I'm sure if you are a Yoruba person, you will know what bese is. And if you are not in Nigeria, bese means, how do I put it? So I need you can interpret bese for
you enter into debt. You enter into debt.
You run at loss. That is what bese means. You run at loss. Big one. You just realize that you installed a rooftop system of maybe, let's assume 200 kilowatts. That's all you installed. Then at peak 1 hour, you realize that what is generating is not nothing to write about. Your hands, instead of you to pay back your money within 5 years, just rather within 3 years, nothing. You are not even close to realizing your money. You are not even close to realize the payback period. So temperature is very, very important. And we are going to see there is a formula, and there is even a test. but we're not going to treat that. When we get to the next training section, we're going to look at that. So temperature is very, when you look at the open PV module, as the temperature increases due to environmental changes generated by power dissipation, production, voltage, VOC decreases. All right? This in turn reduces the power output. All right, so that is it reduces the open circuit voltage, which in turn reduces the output power. Obviously, if you are doing a design, you wouldn't want the power to reduce. If you are doing an installation, you wouldn't want the power to reduce. So this is to let you know that C&I design is not all about my tech universe. Please mute your mic. My tech universe, please mute your mic. Olufemi, your hand is up. You want to ask a question?
Yes, sir. All right.
All right, ask your question.
Okay, my question is just that I think there was a couple of times we were talking about electrical resistance being increased while the voltage will decrease. I just need more clarity on that one. I think I wasn't paying attention at that particular time, and I think I was kind of distracted. And also, concerning the voltage decreasing and the temperature increasing, I need more clarity on that also. And also, we follow that the temperature at room, the room temperature is 25%, and it's only the solar panel. I still don't get the temperature, how the temperature is connected. Okay. I just don't get that one.
Okay, so thank you. So the temperature that we are talking about is the surrounding temperature, the ambient temperature. That's what we are talking about. Do you understand? And so as your solar panel is designed under an STC condition. The temperature is 25 degrees Celsius. All right. So that means you should be able to maintain that temperature. If not, see how you can optimize your system so that you can factor in the temperature the ambient temperature, the cell temperature into your design. That at the end, even if the temperature increases, you are still within the capacity range. You understand? Because obviously, there is nothing you cannot do anything with the temperature. You cannot say all this in a certain location and you be praying that no, you cannot do anything. There is nothing you can do with the temperature. The temperature of that location left to know how to factor in those temperature into your design so that you still maintain that capacity. Where your installation is taking place will reduce the output power. All right, so just take note of that. All right, so now let's quickly move on. We still have a lot to talk about.
And the electrical resistance. As electrical resistance.
Okay, yeah, we okay. Talked about electrical resistance. Once the electrical resistance is decreasing, the current will increase. And once the current is increasing, I'll have an efficient system. All right, so now let's move quickly. We have our mounting structure, mounting types of PV. This is roof type, this is pole type, and this is for those in what's it called, telecom, they use pole at times. Then for ground mount, this is the system that I love. So for roof mount, it is simple and cheap to install because you're not buying the roof, you already have the roof. No flexibility in orientation. Like I mentioned, the roof already, you cannot what you can do about it. Now, this is another type. Integrated PV as well. The thin film, it's only good to see with the eye, but the money is not there. All right. And if you are in Lagos here, Sterling Tower, I'm sure you know Sterling Tower. Sterling Tower, the head office of Sterling Bank. That is what they have, something like this. They use thin film. The efficient, it's eating something that's body. It is not bringing in money. All right. So the reason was nobody in CNI will tell you that you should install. We call it building integrated PV panel, PIPV. It's only good to see in the eye, but in terms of money, it doesn't. Now, tracking system. In CNI at times we use track. I have two sites that I'm managing currently now. One is 4 megawatts and the other is 2.5 megawatts. We use tracker. All right, so there is nothing stopping you from using tracking system. It will increase your efficiency. All right, so that tracker EV cells toward by using a light sensor connected to motor. For example, now we all know that the sun rises from the east and sets at the west. So your tracker will be tracking the sun from the east. It will follow the sun anywhere the sun is going. We follow the sun as it's rising from the east, then follow the sun to the west. All right. So if you have this kind of installation, you cannot beat the output. You cannot beat the output energy. The output energy is way better than just installing it, all right, without tracker. So you can see increasing efficiency by 15% in winter and 30% in warm. Now increase it, but the cost will increase obviously. So for you to be able to increase and use a tracking system, you must have done your plus or minus, all right. But bet me, obviously, if you cannot use tracking for just simple installation. The capacity has to be so that is the reason why we use tracking system for larger installation. So we have two types of tracker. We have the solar axis tracker or horizontally. Is either vertical or horizontal. You cannot do the two. Why for dual axis tracker, you can do both vertical and horizontal, tracking the sun wherever the sun is going. So you can see large installation. Now let me even give you this. Let me give you this.
Question.
Oh yeah, ask your question.
So for that BIPV, sir, do you think is efficient enough for like that Sterling Bank headquarters in PI?
Sorry, do you think?
Yes. The type of PV installation. You mentioned BIPV. Will it be an efficient type for those guys?
They just want to make a name. It's not efficient. I told you it can't be efficient. Number one, the orientation alone is not there, so it can't be efficient. And if they will be telling you, they can only tell you this word that we have. We like PA, we like publicity very well. And we like to live. See any one of them, they will tell you they don't use generator. That is what is powering them 24. It's a lie. It's a lie. It can't power them. It's not efficient. Do you get that?
Second question, sir. If you install that large capacity, like you said, you have a 4 megawatt capacity of PV. Okay. So what is the overall from your experience, generation, or the maximum you have ever seen if you install 4 megawatts? Thank you.
Okay, of course, I'm for the 4 megawatt, I'm seeing the energy, I'm seeing 2.5. I'm seeing 2.5, I'm seeing 2.6, 2.7. I've seen the maximum I've seen from it is 2.8.
Thank you. Thank you very much. Thank you.
Honorable Femi, your hand is up. Jimo, your hand is up too. Ibrahim, your hand is up. Any one of you should go first. Khalid, your hand is up too.
So I was saying that the maximum output energy that you are doing is 2.8
Ibrahim, which am I?
megawatts.
Let Khalid go. Okay.
So that means that the other 2.8 is remaining is losses.
The remaining, of course, now, of course, it's not like it's losses. You understand? There is what we call performance ratio. You understand? There's what we call performance ratio. Of course, some of them is losses. Of course, if you are designing 2 megawatts, of course you can't get 2 megawatts now. So the
But
rest
that's too much, isn't
you factor in some losses. Sorry?
But that's too much, isn't to, for example, if I'm designing, let's say 4 megawatt and I'm just getting only 2 megawatt.
And it depends on the load as well. You know,
okay,
the PV can only give depending on the load. You get it can only give, for example, now if you have if the client load, you understand, is if the client load is obviously not within that, if the client load is 2.5, obviously you cannot give 3 megawatt. That is not possible. So it works based on the client load as well. You get, but just know that you cannot install 3 megawatts and be getting 3 megawatts. It's not possible.
Okay, thank you.
Yeah, you're welcome. So Alao Latif, your hand is up. Ibrahim, you guys should ask your question. We still have a lot to cover. I'm sure we cannot finish by 12.
Yeah.
Okay.
Thank you. I just want to buttress your point with the question this person asked. Because just like you said, load will determine. It is not as if all the remaining ones are losses. This might be due to load because of the radiance, because of the hybrid controller, and also the kind of generator you are using. Because you will not want your generator to run on lesser load. Running on lesser load might damage the generator. That could be the reason that generation is like that. But I believe when this kind of system is running on grid, you far generate more than that.
All right. All right. Thank you. Yeah, thank you. Thank you for that contribution, Latif. So the system I'm even talking about has no, is a battery system actually. So the reason why I don't want to mention diesel now is because we still come to be with diesel. So this system has battery. You understand? It has battery that is charging and is supplying the client. So the reason why we are not seeing, I'm telling you based on that site, the reason why we are not saying it's based on the load and based on the radiance, because obviously it's based on what the sun is hitting. That's why I'm talking about performance ratio. So factoring this, all right, factoring the radiance with what you give out. Don't worry, we are going to, as we proceed, you get to understand the losses and the radiance as well. All right, so Jimo, ask your question. Emmanuel, your hand is still up. Khalid, your hand is still up. You guys should ask question.
Hello, sir.
All right.
My question is, if you are working with this tracking system,
Okay.
can you hear me, sir?
I can hear you.
Like 10 to 12 panel. How are you going to install the tracking on all the panel?
Why do you want to install tracker for 12 panel?
I'm just saying, for instance.
Okay, for instance. So let me just tell you how the tracker works. Tracker, for tracker, we already have track, they have a marking system.
Okay.
Example, we have Powerways. You understand? We have Powerway. I'm sure you all know Powerway. Okay, if you don't know Powerway, Powerway is one of them. So what they do is they are actually in charge of the system. For example, now you can design if you have 22 panels, all right? One tracker will manage that string. That is one string. You understand? So if you have one string, for example, now if you have 22 strings for your installation, you are going to have 22 trackers. Do you understand that? So you cannot have.
Okay.
There's no how your tracker can manage. No.
Okay.
Because it has to move by the strings. No worry, as you proceed, you will get to understand. I don't want to say more, so that I don't want to start repeating myself again when we get there. All right, so Adeyinka, your hand is up. Yeah. So just know that tracker moves per string. Once you have 12 strings, and that tracker is
Hello, can you hear me? Can you hear me, sir?
Yes, I can hear you.
Okay, good afternoon. Sorry to take you a bit. Concerning the shaded panel, apart from the diode in the junction box, do we still require any additional diode during installation or construction of the solar panel? If that is during installation, do we still require any additional?
No, you don't need any. You don't need any. The diode comes to the panel, so you don't need diode again.
Okay.
You guys
Thank you.
don't need any diode again.
Okay.
All right, Olufemi, ask your question sharply.
Yes, sir. Hello, sir.
Yeah, I can hear you.
Thanks for today, sir. So I want to ask, please, is there any relationship between solar irradiance and temperature? Hello, sir. Do you get my question?
I can't hear you. The line breaking.
I say, is there any relationship between? Hello, is it clear now?
Yeah, I can hear you now. It's okay now. It's okay now.
Yeah, is there any relationship between solar irradiance and temperature?
Solar and pressure.
Solar irradiance and temperature. Solar irradiance.
Solar irradiance and temperature. Is there any relationship?
Like probably is directly proportional. If it increase, the temperature also increase.
No, there's no relationship. There's no relationship between the two of them. Both of them are factors that affect solar panel. There's no relationship between the two of them. So that's the reason why doing the manufacturing of a solar panel, all right, there are three conditions. Number one is the irradiance is they carried out the tests using 1,000 watts per meter squared irradiance. The temperature is STC. You understand? So those are two independent factors that they use to test the panel. So there is no relationship between the two of them. The relationship there is that both of them are factors that affect the solar panel. Do you get that? All right, Jimo, your hand is up. We've not started and it's 12 o'clock already.
Yes, sir.
Jimo, your hand is up.
Yes, sir.
All right, Olufemi, do you want to ask another question?
Yes, based on this, the clarity I want to get is.
Sorry, I can't hear you.
Can you hear me now?
Yeah, I can hear you.
So the clarity I want to get is that you talk about temperature affects.
Man, it's kind of low. I can't hear you. Jimo, your hand is up. Ask your question. Sorry.
Hello, is it clear now?
Yes, it is.
Yes. You said temperature now decreases the overall performance of our panel. But from a practical point of view, around that 10 to maybe 12 to, that's also when we have the intensity.
Okay. I'm not referring to I'm referring to ambient temperature, not cell temperature. I don't know if you understand what I'm talking about. Obviously, if you for example, if you are doing a ground mount installation, obviously the temperature for a ground mount, if you are even doing in the afternoon, there is air blowing. You understand? There is air blowing, so the temperature cannot go as far as 55 degrees. It's not possible. There is air blowing. You understand? But obviously, you definitely have an increased temperature. But like I mentioned, in fact, it's very, very important to factor that in your design. If you're not factoring in temperature in your design is not complete. You are only you're playing with. It's very, very, it's one of the important and important parameters that you need to factor in. One question: do you want us to stop now or we should continue? Because we still have a lot to cover. Do you want us to stop now or we should continue?
Continue.
All right. So I will only take question from Emeka. Then I'll continue. Emeka, you ask your question.
Okay, so my question is simple. So how do you cater when you are doing your design, you are planning for temperature, effect of temperature. So how do you accommodate that into your design? Is it by increasing the number of levels? Is it by how do you problem of temperature? Thank you.
Don't worry, we'll get there when we are designing.
Okay.
Constant temperature. In Europe now, where the temperature is -30, -20, you need to factor in that as well, because in Europe there is what we call maximum string voltage. That is the standard. Every country have maximum for every spread. Stream 1,000 volts. It's a law. You understand? That is the standard, the regulation. You must know it. So once you know that, then when you are designing, you have the string voltage. Then you need to factor in the maximum and the minimum. So we are going to get there. That's so much. Feel everything. Let's just take it gradually. Don't worry. Let's be going gradually. We'll get there.